So I will do the Google Colab. If you still remember, we have this data. And you can see the plot. Okay. The first part is about the data without label. So this is the plot. And then with the clustering, where k equals to 2 or the number of cluster is 2, then we can get the label, whether it is 0 or 1. And then we can get the centroid. So the centroid means the center point. So this is the centroid. And we can check which one is the best k. Okay. So we do the loop from 1 until 11. When k is 1, what will we do? When k is 2, when k is 3, when k is 4, and so on. We can get the elbow method like this one, and we can also get the silhouette score. When k equals to 2, the silhouette score is 0.68. When k equals to 3, the silhouette score is 0.55, and so on. And we can plot the silhouette score. Yeah, this is the result from the first data. Now let's look at the new data. So I have new data, the one that I show you on the first hour. So this is the data. Now I have the label, whether it is the premium phone or a general phone. We can do the plotting. Plot. We can know that this is the premium phone and the left part is the general phone. We do the clustering, and let's suppose we make it 2 clusters. Then we can see 0, 1, 0, 1, 0, 1, 0, 1. So the premium phone, it belongs to cluster 1. The premium phone belongs to cluster 0, and so on. Okay. So you can do the plotting again. And we can check which one is not in the same group. Okay. Now, yeah, you can use the RAND index, or sometimes in other books they mention it as RAND score. In the Python, they use the word RAND score. So in order to get the score, yeah, you need to call the function RAND score. And we can create the confusion matrix. And before you compare with the actual label, you need to change the label into numeric values. So the phone status, okay, the phone status is premium and general. In order to make it into numbers, I'm using the label encoder. Then the phone status will be encoded into 0 and 1. After we have 0 and 1, now we can check the RAND score, the score between the actual data and the cluster data. We have the ACC, and we can also see the confusion matrix. The confusion matrix here is the combination between the actual data and the clustering result. So this is the confusion matrix, and we got not the accuracy, maybe this is the RAND score. So we can say this is the RAND index score or RAND score. The RAND score is 0.8. And we already learned from our materials how to get this 0.8. Next is the clustering with the iris dataset. Let me use the iris from the SNS, which is from the Seaborn. So this is the data. I'm using the standard scaler to normalize the numerical column before we do the clustering. After we do the normalization, let's take a look on the data. Okay, this is the result after we do the normalization. The sepal length, it is in minus. Sepal width, it is in positive value. Petal length, it is in minus. Petal width, it is in minus. So it means this data, it belongs to the lower than the average for the petal length, for the petal width, and for the sepal length. If it is positive, then it is upper or higher than the average. So this one, it is lower than the average of the sepal length. This is lower than the average of the sepal width. This is lower than the average of petal length, and this is lower than the average of petal width. Now I'm concatenating. So I'm combining the data after we do the normalization with the column, which is the species. So now we have the full data again, but for the k-means, I'm using only the numerical data without the label. After we got the result clusters, so I want to know what is the centroid. And this is the pair plot. So you just saw it in the PowerPoint. This is the result from the cluster labels based on the sepal length, sepal width, petal length, and petal width. And this is the pair plot of the species with regard to the attribute sepal length, sepal width, petal length, and petal width. Now, we need to compare and we need to calculate the performance of the cluster. We can see the clustering result first based on the centroid. So we want to know the center point. So the center point is here, the center point is here, and the other center point is here. So this is the plot between petal length and petal width for the cluster labels. If you look at the actual label, this is the petal length and petal width based on the actual label. So this is Setosa, this is versicolor, and this is Virginica. But if you look at this result, the clustering result, it is somehow mixed between group 1 and group 2. So you can see the purple color and the black color, they are here. And there are some black color here. So in this case, there can be some kind of noise, or this is a kind of outliers to this group. And the other group, it is totally in the light color. Light color is the maybe gray, because they are in the range of the centroid. Then you can check based on the actual data, there might be some gap. Okay. The clustering result and the actual data has some gaps. And then we can also check the centroid on the attributes. For example, I want to check the centroid of the petal length and the petal width, and I want to check the centroid of the sepal length and the sepal width. Different attribute will give you different centroid. So for the petal length and petal width, this is the centroid. For the sepal length and the sepal width, this is, here is the centroid. So it is based on the attribute itself. If you look at the sepal length and sepal width, so there is group, this is cluster 0, and this is cluster 1 and this is cluster 2. Okay. Somehow it is a little bit better than Petalink and Petalwave in terms of the visualization. But we cannot say like that one before we do the performance analysis. First, you already learned about the elbow method and silhouette score. We perform those things. We perform the elbow method, and this is the result. If you look at this result, what is your consideration? This is when k equals to 1. Of course, if k equals to 1, it is meaningless. No meaning. We will not choose k equals to 1. So we will choose starting from k equals to 2. This is k equals to 2. And this is k equals to 3. This is k equals to 4. This is k equals to 5. This is k equals to 6, and so on. If we are using the elbow method, which one do you choose? Are you using k equals to 2? Or k equals to 3? Or k equals to 4? If we look at the elbow, okay, if we look at the elbow, then there's an option, maybe 3 or 4, or maybe 2 or 3. Yeah, so sometimes it is very subjective. It can be 2, it can be 3, it can be 4. Now we can select 3. Okay, we can select 3 at this moment. Why? Because we know that there are 3 flowers. And using the elbow method, it is also verified that 3 is in the elbow section. And you can just 3. What about the silhouette score? For the silhouette score, we will choose the highest one, or the value which is nearby 1. When the value is nearby 1, the k is 2. When k equals to 2, the value of the silhouette score is nearby 2. It means, okay, we will choose k equals to 2 when we use the silhouette score. Now, the question is, we have the label, or we have the actual label. And the actual label of our dataset shows that there are 3 flowers. Because we already know there are 3 flowers, then we select k equals to 3. Even though the result here, k equals to 3 is lower than k equals to 2, but the domain data shows that k is 3 because we have 3 flowers. Then let's try to perform the analysis result with k equals to 3. In this case, we can perform the extrinsic, or we can perform the RAND index. Using the method RAND index that I mentioned before, we want to see the pairs. For every pairs in the data set, because here we have 150 data, it is too much. So I cannot show you with the visual. So you can check how to measure the RAND index. And this is the confusion matrix. The index 0 here is setosa, and the setosa belongs to cluster 1. There are 33. The setosa belongs to cluster 2. There are 17. The index 1, or the label 1, I think this is the versi color, belongs to cluster 0. There are 46. And the data versi color belongs to cluster 2. There are 4. And the index 2, which is Virginica, it belongs to cluster 0 for 50 data, and the remaining are 0. And you can calculate the random the RAN index is this amount, 72, 0.72, or sometimes we call this is 72%. In some cases, this is considered as good because it is still higher than 70%. But of course, we want to get higher. The higher is the better. Now, my question is, do you think the RAN index performance will be better with the original feature values? What does it mean by these original feature values? In the middle of the flow, we perform normalization. What is normalization? We transform the numerical value from the original value into Z normalization. So we want to fit the data into the mean and the standard deviation. Now, if you do with the Z normalization for the data, you got the RAN index is 0.7. What about if you just do with the original value? Do you think the Ri will increase, or do you think the Ri will decrease? So this is a question. Please check. You can run by yourself the code at home and check whether the Ri is increasing or the Ri is decreasing, or maybe the Ri is the same. Okay, please do this one at home. There might be some question on this one for your final exam. Okay. The last one that I want to explain is about the hierarchical clustering. I want to show only the result. In the hierarchical clustering, we can see the dendrogram, or this is the hierarchical clustering result. In the literatures, we call this is dendrogram. So if we cut this one, then we can get 3 clusters. So the cluster 1, cluster 2, and cluster 3. If we cut from this one, we can get this is cluster 1, this is cluster 2. So if you cut here, then you will get cluster 1, cluster 2, cluster 3, cluster 4, and cluster 5. So it is based on the line. So the line, yeah, it shows a distance. If you cut off here, then you will get 3. If you cut off here, you will get 5. If you cut off here, there will be 2. Okay. So you can do with one of the method, which is agglomerative clustering. And again, we can specify how many clusters do you want to create. Let's suppose I'm using the Euclidean, and there is another parameter. The parameter is linkage, and we use word. So in this class, I will not explain in detail. So let's just use word, because usually this will give you the best performance. So after we have the cluster with the agglomerative clustering with n equals to 3, again, I'm using the RAN score and check the performance. I want to check the performance from the species encoded and the cluster labels based on the agglomerative clustering. And then I print the RAN index, and the RAN index is 0.82.5. Previously, with the k-means, we got 0.82. 7. With the agglomerative clustering, we got 0.82825 something something. Then it means the agglomerative clustering has a better clustering compared than image. Yeah, we can use another kind of clustering. Of course, yeah, there might be another method, but for this course, I will just teach you the k-means and the hierarchical clustering with the agglomerative clustering. Okay. Actually, I want to share something about the Gradio. Let me just share a little bit before you do the quiz. So I give you the in this section in the Kangi Jario, you will see one more Google Collect. So in this Google Colab, you will see how to use Gradio. Gradio is one of the packets in the Python you can use to show your result in web. So let's say I'm doing with the data. So there is a data air passenger, and I'm going to use the line plot. So line plot means I'm going to plot the data along with the line. So you can get the plot, and it is live on the web. And then if you click this one, so you can get this one as a link, and then you can see the result on the web directly. And it is not that complicated to use this Gradio, because with only 4 lines, you can immediately show the result. Okay. So let me show you with the iris dataset. Yeah, we got the iris dataset from the seaborn, and let me do with the scatter plot. So I'm just using the scatter plot from the Gradio. I want to plot the petal length and the petal width, and the color will be based on the species. Then you will see this result. If you click on this one, then you will see the plot, and you can see it on the web. Okay. Yeah, I'm actually expecting you to use the Gradio to show the result, but maybe due to the time limitation, I cannot explain all the things. So I will explain more about the Gradio on the week, I think next week. Okay, I will explain more details about Gradio, how to use Gradio, and how you can apply the machine learning in Gradio. So now it is only to show how the Gradio works and how you can show everything in Gradio. For example, this is the scatter plot, and the other is the bar plot. So you can also look at the bar plot, and then you can see how many of the data with regard to this distribution. For example, the petal length, the petal length. For the petal length in between 1 and 2, there are 50 data. For the petal length between 3 and 4, there are 11 data. We have 43 data, and there are 35 data. And you can also look at this one. This is on the web. You can just refer to the link. And the good thing for this Gradio is the link is valid for 1 week. So you can use the link for 1 week to share with someone. And then You don't need to understand the HTML. You don't need to understand the web system. You can just download the Gradio and then you can run it in your Google Colab. Yeah, this is only just a demo. We will learn more about this Gradio next week, so you can apply it in your project. And beforehand, yeah, if you want to apply the scatter plot, the bar plot for your data, you can try with this simple example. Okay. I will stop here.